Okay, so we've talked a little bit about simplifying radical denominators, but now we're going to get into the whole process. If there's just one radical, if there's two terms with radicals, and that kind of thing. Okay, so something to remember is in order for a radical expression to be in simplified form, if there's a denominator, it cannot have a radical in it. If it does, it's not simplified. And so what we want to do is called rationalize the denominator. Okay, so that's the process. So that's what we're going to practice here. We talked a little bit about it when we were doing that patterns sheet where we compared decimal forms. So these we're just calling simple denominators. They're just one term with a radical in it. So take a look, first of all, is it square root? Yep. So what do we multiply root of 5 by to get rid of, to make it have a perfect square radicand? Well, you multiply it by itself. So we're going to multiply top and bottom by root 5, because whatever you do to the numerator, you have to do to the denominator and vice versa. So that's going to be 2 root 5 over root of 25, which is just 5. So you don't have to show steps for it. If you can, then divide out the coefficient with the denominator, do so, but in this case you can't. Next is also root 5, so same thing in the denominator and then in the numerator. Oops. And so that's going to be root 15 over 5. Nothing can simplify. This is not, it has no factors that are a perfect square. Here, root 6, top and bottom, so that's going to be root 12 over 6. Now, this one, we need to simplify root 12. That simplifies to 12 is 4 times 3, so that's 2 root 3 over 6, and then 2 goes into 6 3 times. So this is really root 3 over 3. Now, if you wanted to, you could have done different here to divide out. You could have, so by dividing the 2 in the radical by the 6 in the radical, that would be 1 over root 3, and then rationalize that. This is just as easy, right? So here, root 3, so that's 3 root 15 over 3. Those 3's divide out, so root 15. This one, I see that 6 does go into 12, so I'm actually going to do that, 4 root 2 over 3, and then I don't have to rationalize anything. Now, saying that, what would we do if we didn't notice that? Okay, well, this is the original question. So you could simplify that if you wanted to. I wait till the end because you may have to simplify twice. If you didn't notice that 6 goes into 12, then you'd multiply numerator and denominator by root 6. So that'd be 4 root 72 over 3 times 6 is 18. Then simplify root 72. That's 9 times, no, that's, 9 times 8, so 36 times 2. So that's 36 times 2, which is 6. So that's 4 times 6 is 24 root 2 over 18. And then 6 goes into that 3 times, into this 4 times. So you get 4 root 2 over 3. Way faster if you can see that 6 goes into 12. Okay, now the next one, notice it's a cubed root. So one thing that you could do here is you could actually divide. 9 divided by 3 is 3, and you're actually done. Okay, but if you didn't notice that, I'm just going to recopy the question. Actually, just let me make that a little bit smaller. So cubed root of 9 over cubed root of 3. So if you didn't notice that, how do we rationalize this to get it to be a perfect cube? in the radicand? Well, we would have to multiply by cubed root of 9. Then we'd have cubed root of 81 in the numerator and cubed root of 27, which is 3 in the denominator. Then we simplify the numerator. Cubed root of 81 is 27 times 3. And cubed root of 27 is 3 cubed root 3 over 3. Those divide out and we get cubed root of 3. So you can see how much nicer it was to notice that we could have simplified that to start with. Okay, so that's rationalizing the denominator when it's just one term with a radical in the denominator. Now we need to get ready to do fractions that have two terms. So we talked a little bit about conjugates in previous lessons. What is the conjugate of root 3 minus 2? So you can find a conjugate if it's got two terms in it, whether it's polynomial, so a binomial, or whether it's a radical binomial. So here, conjugate of this has the same terms, but opposite sign in between. Conjugate here, same terms, opposite sign in between, minus. Multiply the radical expression in A by its conjugate. So root 3 minus 2 times root 3 plus 2. If we use FOIL, then that's going to be root 9, which is just 3. Get in the practice of simplifying in your head. Plus 2 root 3, minus 2 root 3, minus 4. And these add to 0. They're opposite signs. So 3 minus 4 is negative 1. So we now went from an expression that had irrationals to the simplified, which is rational. Then do the same for B. So 4 times root 25, which is 4 times 5, is 20. Minus 2 root 35 plus 2 root 35 minus 7. Those add to 0. So what you'll notice is these two terms always add to 0. So what you end up with is the first term squared minus the second term squared. So first term squared is 20, second term squared is 7, subtract, you get 13. First term squared is 3, second term squared is 4, subtract, you get negative 1. So you get the first term squared minus the second term squared. Rational number. Okay, so rationalizing complex. So by complex, we're not meaning complex numbers, which you'll learn about later. We just mean it's more difficult than the ones we already did. So we want to multiply. If you're multiplying the denominator, then you have to multiply the numerator. So that'll be 2 root 3 plus root 7. So this will be 2 root 3 plus root 7. Always has to be the same. So sometimes I leave it in factored form in the numerator until I see what the denominator simplifies to. So now first term squared is 4 times 3 is 12. Second term squared is 7. And then I notice that'll give me 5, which doesn't divide into 11. So now I expand that out. So that'll be 22 root 3 plus 11 root 7 over 5. That's rational, right? So you've now rationalized the denominator. This one, This will be root 10 plus root 3, top and bottom. I'm going to put it underneath here. So again, I leave the 7 just till I see what the denominator simplifies to. That's going to be 10 minus 3. And I see it does simplify to 7. So that divides out with this, and you're just left with root 10 plus root 3. Okay. And here, next question. So this will be root 6 minus root 2, top and bottom. And so again, I leave this out. You don't have to, but it might save you some time. Then that's going to be 6 minus 2, okay, which is 4. And so it will divide out in there. But I also see some expanding here. So I'll leave it like this for right now. Okay, and then 2 goes into that once, into this twice, and then I expand. Root 6 times root 6 is 6. Root 6 times negative root 2 is minus root 12 over 2, and then I can simplify the root 12. So that's going to be 6 minus 2 root 3 over 2, and now I can divide out 2 into everything. This 2 has to go into both. So it's kind of like factoring out a 2 from the numerator and then dividing. Now, if you can see right away that 2 goes into both, then you can do that. But don't forget, it has to go into the coefficient of the radical. Okay, next here. I guess that's it for, oh no, up top here. Sorry, I knew there was more. Okay, so here the denominator, we look for the conjugate, so root 3 plus root 2. Turns out that that happens to be what the numerator is. So really, here when you have 2 terms in the numerator, then I start expanding that out as well, because likely you're not going to be able to divide out without doing that. So you're really squaring root 3 plus root 2. So again, use FOIL if you need to. That's going to be 3 plus root 6 plus root 6 plus 2, which is really 2 root 6, if you want to do it the fast way. Then the conjugates will be 3 minus 2. And so here this will be 3 plus 2 is 5, plus 2 root 6, and 3 minus 2 is 1. So you don't even show the 1, and you're done. And then here the conjugate is root 6 minus 3 root 10. Root 6 minus 3 root 10. And again, you've got 2 terms, numerator, denominator. So FOIL, so that's going to be 3 root 12 for the first together. Outside will be minus 9 root 20. Inside will be plus root 30. And last terms will be minus 3 root 50. Squishy here. Denominator will be 6 minus 3 times 3 is 9 times 10 is 90. Then simplify any radicals that you can. So that's going to be 2 root 3. 2 times 3 is, so that's 6 root 3 minus root 20 is 2 root 5. So that'll be minus 18 root 5 plus root 30. 50 is 25 times 2, so that'll be minus 3 times 5 is minus 15 root 2 over negative 84. Now, notice you can't simplify any of the radical terms there. Take a look. This is even, but there's no coefficient there, and this is not even, so you can't divide that out. The only thing is it's negative, so we don't like having a negative. So I would divide every term in the numerator by a negative 1. So that'd be negative 6 root 3 plus 18 root 5 minus root 30 plus 15 root 2. all over 84. Okay, and that's it.